Tree diagrams. Tree diagrams can be used to illustrate sample space, provided that the alternatives are not too numerous. The advantage of a tree diagram is that they can be used when more than two operations are involved. So before we've been looking at the sample space, but now we're looking at a bigger sample space where more than one thing is going on. So let's have a look at what a tree diagram looks like. Two coins are tossed simultaneously, and we're going to use a tree diagram to show this. So when I think about tree diagrams, you just need to think about the two things that are happening. The first thing is I'm tossing one coin first, so that's the first thing I have to do. If I toss one coin, I can either get a head or I can get a tail. And then I'm going to toss another coin. Now, if the first time I got a head, the second coin I toss, I can also get a head or I could get a tail. If my first coin showed a tail and then I toss my coin again, I could get a head or I could get a tail. And this is my probability tree, and that's how easy it is. Now, of course, the other thing we have to do is list the outcomes. This is like your sample space, all the events that could possibly happen. So I could get a head and a head, and this is how we read off our probability tree diagram or our tree diagram. I can get a head or I can get a head and a tail, or I can get a tail and a head, or I can get a tail and a tail. And that's how easy it is. So let's have a look at my next example. We've got two marbles that are drawn from a bag, and the bag contains one red, one blue, and one green. So I've got two marbles in a bag, or the two marbles I'm drawing from my bag. So the first marble that I'm going to draw could be a red, or it could be blue, or it could be green. And then I'm going to draw a second marble. Now, if I've drawn a red one, that means there aren't any red left in there. So, on my second draw, I can only get a blue or a green. And for the next one, if I choose a blue first, the only thing I can get is a red or a green. And if I chose a green first, the only thing I can get is a red or a blue. And then I can list my outcomes, all the variations I can get. So I can choose a red and then a blue, a red and a green, a blue and a red, a blue and a green and a red, and a green and a blue. And that's how easy it is. Let's have a look at this next one. John plays Peter at tennis, and the first to win 2 sets wins that match. Let J be John wins a set and P be Peter wins a set. So let's have a look at this. What's going to happen? We've got our first set, and the thing is, John could win or Peter could win. That's set 1. And then I'm going to have a look at set 2. Now, if John wins first off, John can win the second set, or Peter could win. And if Peter wins first, John could win, or Peter could win. Now, the thing is, it's a first to win 2 sets. But what happens if we have John and then Peter? If I do John and then John wins set 2, then he's won overall because it's a first to win 2 sets. But if no one wins, we obviously have to play again. So if John wins first, then Peter, then they're going to play again, and John could win or Peter could win. And if Peter wins first and then John wins the second game, then John could win the third set or Peter could win. So now our outcomes look slightly different. So my outcomes now are John, John. That's the first branch of my tree. Then I've got John, Peter, John. So J, P, J. And I've got J, P, P. And then I've got P, J, J. And then P, J, P. And P, P. And these are all of the outcomes. And that's how easy probability trees are. Thanks for watching.